In this video, we'll review how to find the circumference and arc length. To begin, let's look at some circle vocabulary. A circle is the set of all points the same distance from a fixed point. In this case, if we take point G and find all the points the same length from G, we get circle G. It's named using the circle symbol and a capital letter. The capital letter refers to the center of the circle. The radius is the distance from the center to any point on the circle, versus the diameter, which is any segment that goes through the center and has both endpoints on the circle. The diameter is a special type of chord. Chords have endpoints on the circle, but the diameter is a special chord because this chord has to go through the center. Now the diameter is always twice the radius, or thought differently, the radius is half the length of the diameter. Now when we solve circumference problems, we're going to use either diameter or radius, and we'll look in a minute how we can use those two formulas. But before we do that, we should probably define what circumference is. The circumference can be thought of as the perimeter, or better yet, the distance around a circle. And as I said, there's two formulas. One is the circumference equals pi times diameter, or we can use circumference equals 2 times pi times radius. Now both formulas are really the same thing. The diameter is twice the radius. So really the formulas are the same, it depends on what your input is. If we know the diameter, we're probably going to want to use circumference equals pi times diameter. But if we know the radius, it would make more sense to go circumference equals 2 times pi times radius. Now let's look at a couple examples of these. Okay, our first example is this one. If we're told, find the circumference of a circle with diameter of 2.5 inches. Now, is there a circumference formula that uses diameter? Think carefully. Yeah, we can just say circumference equals pi times diameter. If we substitute in our diameter as 2.5 inches, we get the exact answer. We get circumference equals 2.5 pi measured in inches. Now in circumference problems, we're going to want to give both an exact and an approximate answer. So in this case, we'll say that the circumference is 2.5 pi inches, and then we'll use our calculator to approximate. That's about 7.85 inches. Now take a look at the next problem and see how that one's a little bit different. This time, instead of being told the diameter, we're told the radius. In which case, we're probably going to want to use a different formula. Because we have the radius, we probably want to go with this one. The circumference equals 2 times pi times radius. If we substitute in our 6 inches, we get 2 times 6 pi, or better yet, it's 12 pi inches. Now that's the exact answer. That's one of the two ways we want to show that. We also want to approximate, so we'll take our calculator, take 12 and multiply by pi, and find out that it's about 37.70 inches. Now perimeter is a single unit. It's a single dimension. Therefore, we just say it's inches and not inches squared, unlike area. Now look at letter C and see what's different here. This time we're not told diameter and we're not told radius. Instead, they tell us the area is 81 pi inches squared. Now there is no circumference formula that uses area, so I'm going to have to take that area and use it to convert it to something more useful. I know that the area of a circle is pi r squared. I can use this formula, substitute in the 81 pi for area, and solve for radius. Once I know what the radius is, I can then substitute that in to the circumference formula to actually find the circumference. So this is going to be a multi-step problem. So we'll substitute in the 81 pi for the area, and I want to solve for the r. Now I see on the side with r, I have a pi on it also. So if I divide both sides by pi, the pi's will cancel, and I'm left with 81 equals r squared. Now I don't want the radius squared, I want simply the radius. The way to undo a square is to square root it, and the square root of 81 is 9. So I find that the radius is 9 inches. Now think what formula, you can look up top, would be the best one to use next. Hopefully you came up with circumference equals 2 pi r because we know the radius. If we substitute in the radius is 9, 2 times 9 is 18, and we get the exact answer is 18 pi inches. We also want to approximate, so we take our calculator and multiply 18 times pi, and we find out it's about 56.55 inches. Now let's look at how to do the arc length. Now that we know how to do circumference, we can find the arc length. Now recall, arc measure is the measure in degrees, which is the same as the portion of the central angle. Now it's always going to be a piece of 360. So if we want to find the measure of angle AOB, that would be the same as the number of degrees, or the arc measure, in arc AB. Now that's going to be different than arc length. Arc measure is degrees. Arc length is how long, what the actual distance is, if you had to actually walk across that arc. Now the way that we're going to find the length of arc AB is we're going to do it very much like we did area of a sector, if you've already watched that video. It's the piece out of 360, either the measure of the arc or the central angle, times the circumference. Usually we're going to use 2 pi r here. So let's look at an example of how to do this. This problem is based on the picture above. If the measure of angle AOB is 60 degrees and the radius of our circle is 5 centimeters, we want to find both the arc measure and the arc length. Now to do the arc measure, we know that the arc measure equals the central angle. Now I'm going to have to pen write this one in because I did not have it. So in this case, we know the arc measure equals the central angle, which means the measure of that arc, in this case AB, is the same as that central angle, which is angle AOB. So I know the measure of the arc is also 60 degrees. Now that is not going to be the arc length. The arc length is going to be something very different. Instead of being the number of degrees, the arc length is physically how long is it if you had to walk along that piece of the circle from point A to point B. So let's look at how to do that one now. Okay, if we know the angle and we know the radius, we can find the length. The length of that arc is going to be the piece out of 360, so 60 over 360, times the circumference, which is 2 pi r. However, r in this case, the radius, is 5 inches, or 5 centimeters rather. So we can reduce the fraction next. If we take 60 and divide it by 360, we'll get that it's 1/6. And then 2 times pi times 5 would be 10 pi. So we get 1/6 times 10 pi. Now multiplying that fraction together, 1/6 times 10 would be 10/6, and we can reduce it to 5/3. So the exact answer would be 5/3 pi centimeters. Now this would be the exact answer. We also want to approximate. So if we take the 5/3, multiply by pi, we'll find the approximation. In this case, it's about 5.24 centimeters. Now again, I want to emphasize arc measure and arc length are different things. Arc measure is the number of degrees, which we found to be 60 degrees, and the arc length is how long it is, the distance, which is about 5.24 centimeters. All right, hopefully this video helped you, and thank you for watching.